Hi guys, this is Algebra Lesson 2-2, and you can follow along in your textbook from page 83. Today we're going to talk about some real basic tools for solving equations that become extremely powerful and extremely necessary even as you go higher and higher in math. They're very basic, but they're things that we use all the time when we're doing algebra. The first is called the addition property of equality, and let me show you why it works. I think you might agree with me that 3 equals itself. 3 equals 3. And remember that the equal sign means that both sides have to be balanced. They have to be equivalent to each other. So in this case, 3 obviously is equivalent to 3. What would happen if I added 2 over here? I would get 5. 5 doesn't equal 3, right? But if I were to add 2 over here, I get 5, and we would agree that I still have a true statement, 5 equals 5. I can add anything I want to. Well, let's add a -2 just for fun. And I would go back to 3 equals 3. I can keep adding whatever I want to as long as I add it to both sides. That's the key. So, for example, if I wanted to solve this little equation over here, I want to know what v is. I don't want to know what v minus 9 is because that's kind of hard to understand, but I do want to know what v is. So I'm going to choose to add 9 because minus 9 plus 9 just gives me 0. And so if I have v plus 0, I'm just going to have a v, right? I'm not allowed to just do that out of the blue, though. I have to do whatever I did on the left, also on the right, to keep it balanced, right? So if I want to add 9 whatevers on the left side, I'm going to also have to add 9 whatevers on the right side to keep it exactly balanced and fair. So 14 and 9 is 23, and now I know what v equals. So that's the addition property of equality. I can add anything I want to both sides of an equation, and I use that to my advantage to try to get a variable by itself so that I can see what the answer that I'm looking for is. Okay, the next thing I might want to do is I might want to use the subtraction property of equality. So let's do something again. Let's start with maybe the number 10. And notice that if I want to subtract, let's say 4 over here, I would get 6. And that wouldn't be the same as 10 anymore. But if I would subtract 4 over here, I would get 6, and it would stay balanced. I can keep doing that. This is a really simple explanation, but at the same time, I think you can see that I'm keeping things equal. I'm keeping my balance between the left and the right, and I'm making equivalent sides. So here's how I use this to my advantage. If I have a plus 26 equals 35, and I want to get a all by itself, I might choose to subtract 26 over here, because adding 26 and subtracting 26 cancel each other out. 26 minus 26 is 0. And so I would end up getting that a all by itself, which is what I want to do. That's my objective. But I can't just do this. This is incredibly lopsided right now. Whatever I've done on the left, I must do it on the right. And so I'm going to have to subtract 26 over here also. And I'm going to get 9. A equals 9 is my final answer. And that's the solution I was looking for. The next thing I might want to choose to do is called the multiplication property of equality. And again, let's say I'm going to start with, say, 8 equals 8. Notice that if I times by 2 over here, I'll get 16, which doesn't equal 8. But if I times over here, I'll get 16 and keep it equal. So as long as I do multiply by whatever I want to on the left and do the same thing on the right, I will be fine. So here's how I use this to my advantage. T over 7 is the same as t divided by 7. If I was to multiply times a 7. And a lot of you don't like to think about fractions, so think about 7 as 7 over 1. If I were to multiply by 7 over 1, I would end up with 7t over 7, or the 7's would cancel, correct? And so I would end up with t, or t over 1, all by itself on the left. I'm not allowed to just isolate that. I have to come over here and do this also. I'm going to multiply by 7 over here. And if you wanted to think about this all in fractions, these are over 1 also. But we don't have to do that. -5 times 7 is -35. And then I have gotten t by itself. Likewise, the division property of equality allows me to divide by anything I want to. Let's say I have 15 equals 15, and I divide by 3 over here. And notice that I drew a line for divide by. I just like doing it that way. Notice it is staying the same. And I can divide by anything I want to, as long as I do it to both sides. Here's how I might use that to my advantage. Over here I have -4a, and I want this a by itself. This is really -4 times a, right? And I'm going to divide by -4, because -4 divided by -4 is just 1, +1. And so I will end up with 1a, which is really the same as a. These two expressions are exactly the same. I can't just divide by -4 on the left. I have to come over here and do it on the right. And I will end up with a negative. Positive divided by negative is a -12. All right, let's maybe do a couple examples from the book. I'm right at the check your understanding, and this would be a great opportunity for you to pause these and try a few of these. Pause these and try a few yourself, and then see how you do. 6 plus 5 equals 33. Pause right there. I want to use the subtraction property of equality in order to get g by itself. How about 104 equals y minus 67? And remember that you can pause this and try it yourself. I'm going to use the addition property of equality to cancel this out. And this is the same as saying y equals 171. If they are the same, balanced on each side, we can flip them around to our advantage. Let's do one with a fraction. Okay, remember, this is high school algebra 1. You can have a calculator so that you don't have to feel like the fractions are slowing you down. Here I'm going to use the subtraction property of equality because I'm trying to get the w by itself. So I have w, so it's canceled, equals 1 1/2, which if I have to do this by hand, that's odd. Goes back, please go back. Not sure what's happening here. There we go. Let's have a little fraction review. 1 1/2 is the same as 3/2. I did 1 times 2 is 2, plus 1 is 3 on the top, minus 3, or 2/3. And I need a common denominator. If I multiply by 3 on the bottom, I have to multiply by 3 on the top. If I multiply by 2 on the bottom, I have to multiply by 2 on the top. And w equals 5/6. All right, I'm going to pick one that I think is going to be more a problem. Let's skip over to number 47. I have 2/3 equals 1/8 y. So I want to use the multiplication property of equality here because I'm thinking about what will cancel out 1/8. 8/1 will cancel out 1/8, right? And that would give me 1. And so I want to multiply both sides by 8. Okay. This is canceling with this, and I have y on the right. And here, over here, I have 16/3. Don't worry about your improper fraction. 8 times 2 on the top is 16. Right, here's another one that's good for you to see. 2/3 n equals 14. If I want to get rid of a fraction like 2/3, I can multiply by its reciprocal, because then I end up canceling everything and just getting 1. So make sure you multiply by the reciprocal over here, and to get n equals 21. Multiply the tops. All right, if you want to stop right here and go work on your Alex homework, that would be fine. I'm going to work a few examples from that homework. Here I have -3 equals v minus 7. I'm going to use the addition property of equality. Here I have 3u equals 84. I'm going to use the division property of equality. Have you noticed a pattern? If we're multiplying, we're going to divide to get rid of it. If we're adding, we're going to subtract to get rid of it. Adding and subtracting go together. Multiplying and dividing go together. Ooh, that's kind of yucky. That may not be simplifiable, so we can just leave that, I believe, as 84/3. 3 doesn't go in there equally, so. Don't be afraid of fractions that look like this. Notice I didn't sweat that, I just wrote it. I actually didn't even have to do any thinking. 2 equals 6x. Here's another thing that trips people up. I want to use the division property of equality and divide by 6, right? Don't let this mess you up. Some people will answer now 3, but notice that there's a 2 on top of a 6, and if I simplify this, I'm going to get 1/3 equals x, or x equals 1/3. Keep the top on the top and the bottom on the bottom. Don't let your brain flip it around and say 3. Here I'm going to use the division property of equality because I'm undoing this multiplication. Negative divided by negative is a positive. V equals 15. And a word problem. Henry is on the way home in his car. He has driven 30 miles so far, which is 3/5 of the way home. What is the total length of his drive? If we want to use x for the total length, or that's another way of saying the way home, that's going to be x. So I'm defining the variable. He has gone 3/5 of x. Of always means multiplication. And he has gone 30 miles so far. We can put 30 on the left or on the right. He has gone 3/5 of the way home, which equals 30. To get rid of the 3/5, I'm going to use the multiplication property of equality and flip 3/5 over so that it cancels. Remember that you can use a calculator, or you can challenge yourself a little and then back yourself up so you don't make silly mistakes. All right, that's the end of that, and let me know what you have problems with.